Hello geometry team, and welcome to Unit 6, Day 3. We are going to be continuing proofs of congruent triangles, but today we are throwing in a twist where the triangles are going to be overlapping or connected to each other in some way. So to begin, we're going to start with this one. And it says we are given that KA is perpendicular to segment AR. So that's this part right here is telling me that KA is perpendicular to AR. I know that perpendicular means right angles, and so I'm going to mark it here, but I'm going to also remember that I have to say that somewhere in my proof. I can't just leave it there in the picture. I also know that segment YR is perpendicular to segment AR. Here's YR and here's AR, and I know they're perpendicular. And I know that angle AKR is congruent to angle RYA. So AKR is going to be this angle up here, and RYA is going to be this one up here. The thing I'm trying, that was the green. The thing I'm trying to prove is that triangle KAR is congruent to triangle YRA. Now these triangles overlap, and it can be tricky to figure out what goes with what, and so something that I highly recommend when you get triangles that are overlapping in any kind of way is to draw them separately. So I'm going to draw a triangle KAR just underneath where it is here. So here's K, here's A, and then I know that it comes across here to R. And it has this red angle that I already decided was in it, and it has this green one. Now I'm going to focus on triangle YRA. Triangle YRA goes from here down, so Y and R, and then across over to A, and comes back up. That one has this angle, angle RYA, and then I also knew that they were perpendicular. And I'm trying to prove that these two triangles are congruent. So now I'm ready to begin. I'm going to be looking for three pieces that they have in common that are congruent. So I'm just going to set up my two columns here, and I'm going to start with all my givens. I know KA is perpendicular to AR. I know that YR is perpendicular to AR, and both of those are givens. I also know that angle AKR is congruent to angle RYA. That's also a given. Now this green guy right here, that is an angle that both triangles have congruent. So I'm going to mark that they both share that angle, and I'm on my way to one of my three-letter congruence postulates. So now I'm going to go on to a new step and say, well, what else can I prove from these givens? Well, from the perpendiculars, I can say that angle KAR is a right angle. So I know that angle KAR, and I know that angle YRA, and angle YRA are both right angles. And I know that they're both right angles because I was given that they're perpendicular. So I'm going to use the definition of perpendicular as my reason, because if things are perpendicular, they make right angles. Well, using that now, I can now say that if these are both right angles, they must both be congruent. So angle KAR must be congruent to angle YRA. And I can say that because I know that all right angles are congruent. That's my right angles. It's called the right angle congruence postulate, but you could just say that right angles are always congruent, and I'll know that you understand that that's what it is. And now when you say that, these red angles, now you're saying that they are congruent. So now I have a set of angles congruent, and I have another set of angles congruent. And so thinking about my three-letter congruency schemes, I know that if I have angle, angle, I either need to have angle, side, angle, or I need to have angle, angle, side. I can't use angle, angle, angle because that one does not prove congruence. So I need to look for a side that could possibly be congruent. And when I'm looking at these, I remember that these triangles do overlap, and each of them has segment AR as their bottom piece. And this bottom piece here is in the same spot in my original picture. It will be congruent to itself. And so this piece down here and AR down here is congruent to itself. So that is going to be something I can say. I can say that segment AR is congruent to segment AR. And I know that because of the reflexive property from our unit previously. Well, that tells me then that I have a side on each triangle that is congruent. And so double checking, I have angle, angle, side, not angle, side, angle. So I'm ready to say now that triangle KAR is congruent to triangle YRA because I had angle, angle, side congruence. And I have finished my proof. Ready to move on now. We have a new picture. These triangles aren't overlapping necessarily. These triangles are touching each other in the middle. So again, if they're touching each other, it's good to watch out for a piece that they share because it will be congruent to itself. So let's look at what we have. We'll mark our picture and set up our givens. I have that angle S is congruent to angle W, and that's given. And so I'm going to mark that angle S is congruent to angle W. And already to prove that these triangles are congruent, I have a piece that I want. I also have that segment SO is congruent to segment OW. And so I have that SO here is congruent to OW here. They are the same size. And that's also a given. And I'm trying to prove that triangle SON is congruent to triangle WON. So I have a triangle on the left and a triangle on the right. Since they don't overlap, you don't have to necessarily draw them separately like this. You could leave them stuck together and still be able to figure out what's going on. So you can draw them separately or you could leave them together. Looking at this now, I go, oh, out of these triangles, I have the green segment is congruent on each of them, so I have a side congruent. And then I have an angle in each triangle congruent. So now I either need another angle or I need another side to prove that these are congruent. So you start looking. I don't have anything perpendicular, so I don't have right angles. But I do have this shared side down the middle, and it will be congruent to itself. So now I can say that segment ON, or you might call it segment NO, is congruent to segment ON. And again, that uses the reflexive property. And that tells me, oh look, now I have another side in each triangle that's congruent. And so I go, okay, setting this up now, I'm going to have, oh, I have a side, and an angle are congruent. Wow, am I allowed to use a side, and an angle to prove that these are congruent? Not really. So I'm going to have to figure out something to say if these are congruent. I can't use angle, angle, side. I can't use angle, side, or side, angle. But do I have any other possible pieces that are shared or congruent on both of these triangles? Looking in here, I notice and I remember that there is one more triangle in this picture, and that is this great big triangle here. Okay, and in this great big triangle, I have these bottom two red angles being congruent. Well, if the bottom two angles in a triangle are congruent, then their opposite sides must also be congruent. So actually, this SN and NW are congruent to each other. So I'm going to come down here into my proof and say SN is congruent to NW. And I know that because it's an isosceles triangle, has base angles congruent. So I used the fact that these base angles were congruent to say that the sides were congruent and that it made an isosceles triangle. And so that is another side that I have congruent. So it turns out that this angle is not going to be necessarily part of how we proved the triangle, but we needed it to get our third piece. So now that I have all three sides congruent, I can say that triangle SON is congruent to triangle WON. And you have lots of options of how you want to prove it. You could use these three sides and say it was congruent by side, side, side. But if you have all three sides, you could also say that I have the green side and the purple side and the included angle are congruent. So you might also say it's because of side angle side. So you have lots of choices here now on how you wanted to prove this. I'm going to just leave these two, and I want you to see if you can figure out what the other one you can use is to prove that these triangles are congruent. Problem number 3 now. Looking at this picture, you'll notice again I have 3 triangles, 1, 2, 3, and then I have a bigger triangle here, JAM, and this bigger triangle, IMA. So we have a lot going on. And the big ones are the ones I'm trying to prove. I'm trying to prove JAM and IMA. These big triangles are congruent, but they overlap. And so to help me see what's going on, I'm just going to sketch out. I have this triangle. That's this red one here. And if you want to, you can even trace them out in one color and then bring it over here so you can see which one you're talking about. So I have this green one and this red one. Okay? And you notice that they share this side on the bottom. And so I'm looking to prove that these triangles are congruent. Let's see what pieces I am given. I can say that JAM is congruent to angle IMA because it was given. And so I'm going to mark that. I'm going to say JAM, so that's this obtuse looking angle here, is congruent to this obtuse looking angle here. So I already have an angle in each triangle being congruent. Then I'm going to say, okay, I have segment AE is congruent to segment ME. And I almost forgot to put those segments on there. Those are very important because we're not talking about lengths, we're talking about segments. And these were also given to me. So I have AE, this little guy here, is congruent to ME, this little guy here. Well, notice that these aren't pieces on my big triangle. AE is just a little piece of this green section. And EM is just a little piece of this red section. So those are not pieces of the big triangle I'm trying to prove. So I'm not going to use that to prove my big triangle's congruent. They might help me figure out parts of my big triangle though. And so that's a good thing to know. So using those, that's where I'm going to start here. These two little pieces are both part of this little bitty triangle here. And if these two segments are congruent, that makes this little yellowish triangle isosceles. And these two little angles down at the points are now going to be congruent. So I can say angle EAM must be congruent to angle EMA because I had the isosceles triangle has base angles congruent. And that made this little angle here congruent to this little angle here. Well, this little angle is in the point of my green triangle. So I'm going to come down here to my green triangle and mark this little guy here. See how he's down here in the green point? Here it is marked in my green point here. And then this little guy down here, angle EMA, is down here in the point of my red triangle. So I'm going to mark it here in the point of my red triangle. Well, oh look, now I have another angle in the triangles I'm trying to prove are congruent. So now I'm going to come over here and say I have another angle congruent in the triangles I'm trying to prove. Well, I'm still not done. I still need something else. You always need 3 parts. 3 parts. And so you go, okay, what else do I have? Then I recall that, oh, look, there's a red and a green overlapping here. AM is part of both of the triangles. I've got this segment here is congruent to itself. So I've got AM and AM. It is congruent to itself. So I can say AM is congruent to AM, and that's my reflexive property. And now that gives me another side that is congruent in each of these triangles. And so you go, okay, now I have 3 pieces. How are they arranged in my triangle so that I can say that triangle JAM is congruent to triangle IMA? Well, it looks like I have an angle and a side, but when you see how they're arranged in the triangles, I have 2 angles on my green triangle and 2 angles on my red triangle, and on both of them, the congruent side is in between. So I actually have an angle and an angle with the congruent side in between, which tells me I have angle, side, angle congruence, proving these triangles congruent. So as you do these overlapping or isosceles triangles, you're going to want to be looking for pieces that are shared, or look for isosceles triangles that might help you prove that angles are congruent. If you want to go on and try the homework, you can. I'm going to work a couple more examples just so you can see things you can prove. Okay, looking at problem number 5 here. I am given that the measure of angle SUT, so that's this red one right here, S to U to T, this guy right here, is equal to the measure of angle RVT. That's this one right here. So I've marked them both in red. And I know that segment RV, that's this guy, is congruent to segment SU. That's this guy right here. And I'm trying to prove that triangle TVR, I'm going to take my purple now, that's this guy, TVR. So I'm going to sketch TVR out here so that he's separate from everybody else. So here's TVR. And then I also have triangle TUS I'm trying to prove. Well, triangle TUS is T to U, so that's this down here, T and U, and then S is down here. So I have this triangle now. So those 2 triangles were way overlapped in my original picture, so I have pulled them out here. And you'll notice that that red angle that I found previously because it was given is not an angle in my left-hand triangle, but it is in my right. Here's it's SUT is right here. Angle SUT is this red one right here. And this red guy, TVR or RVT, is right here. So I have found those angles in the triangles I'm trying to prove. So I'm going to take that and I'm going to start. The measure of angle SUT is equal to the measure of angle RVT. That's a given. And I'm going to go ahead and write my other given. RV is congruent to SU. Okay? Well, RV is in my purple triangle that I'm trying to prove, and SU is in my purple triangle I'm trying to prove. So I have one segment given to me. Now, I got all excited that the measure of SUT equaled the measure of angle RVT and that those were these red ones. But remember, I can't prove the triangle's congruent unless the angles are congruent. So I'm going to have to take another step and say if these measures are equal, then I can say that angle SUT is congruent to angle RVT using the definition of congruent. Remember, we were told that if things were equal, it means that they are congruent. So since their measures are equal, I have to take the step to say that they are congruent to each other. And now I can say that those red angles are congruent to each other. So now I have two pieces of these triangles being congruent. But now I need a third piece. And this is where you go back and focus. Where were these two purple guys inside this thing? And you'll notice that both of them contain angle T up here at the top. Angle T is right here. You'll notice that angle T is this part of this purple triangle, and angle T is also in this triangle. So now I can take that material and go, aha, I had my green sides were congruent, my red angles were congruent, and now I'm going to say this blue guy, this blue angle, angle T, is congruent to angle T. And that's due to the reflexive property. It was up here and it was up here. So now I have another angle. Uh-oh, that gets us suspicious. Let's make sure that I can say that this is acceptable. I have an angle, and then I have the side that is not in between them. So I have an angle, and the side not between. That is one of the postulates I'm allowed to use. So I can say that triangle TVR is congruent to triangle TUS by angle, side, or by side, angle. Those are the same thing whether you write them forward or backward. So that completed that proof. Looking down here at number 6 now, I am given that CA, that's the length of CA, equals the length of GR, and that the measure of angle RGC is equal, I almost wrote congruent. Watch out for that, Mrs. Cerna. You guys need to watch out for that too. Measure of angle ACG. Automatically, I know that since these are equals, I'm going to have to take a step to say that they're congruent if I want to use them to prove anything about these triangles being congruent. I'm trying to prove that triangle GAC, that's this guy, GAC, is congruent to triangle CRG. C, G, and R. And notice that by my order, I'm going to be trying to prove that A is congruent to R, and C is congruent to G, and C is congruent to G. Okay? And so you go, great, I'm ready to go. I'm first going to start with taking these and proving that they're congruent. So I'm going to say that segment CA is congruent to segment GR by the definition of congruency. And while I'm on that step using that, I'm going to go ahead and say that angle RGC is congruent to angle ACG. So I've just taken both of these pieces and taken the step to say that they are congruent to each other using this definition. So now I have that segment CA is congruent to segment GR by the definition of congruence, and that is giving me a side on each of my triangles. Then I have said that angle RGC, so RGC, it's congruent to angle ACG. ACG, that's this guy right here, by the definition of congruence. That gives me an angle in each of these two triangles being congruent. Now I need a third thing. I either need an angle or a side to be congruent. Well, again, remind yourself that each of these contains segment CG right here. That's this piece within my original image is part of each of these triangles, which means that it is congruent to itself. So I can say that segment CG is congruent to segment CG, and that is because of the reflexive property. Everything is always congruent to itself. And that gives me a side in each triangle. So let's see how they're arranged. I have a side and a side in both of my triangles, and then the angle that's congruent is in between them. So I have a side, and then the angle between them is congruent. So therefore, triangle GAC is congruent to triangle CRG by side angle side congruence. So the whole point of all these different pictures and things is to show you that proving triangles congruent in a bigger picture is going to involve some detective work. You're going to be looking for pieces that are shared. You're going to be looking for ways to figure out that different things are congruent based on them being overlapping or based on using an isosceles triangle. So as you go through your problems tonight and in general, be a detective. Look for clues and see what you can have so that eventually you have 3 pieces that you can use to prove your triangles congruent. Good luck, and we'll see you next time.